How can we differentiate the types of bonds in chemical compounds? This is the types of bonding lab. I have here a chemistry mystery. I have 3 containers containing 3 white substances. They look very much alike, but they're not. In fact, they're very different from each other in terms of their intrinsic characteristics. It's not really a mystery, you know. This is sodium chloride, this is sugar, and this is sodium bicarbonate. All 3 of these very common compounds are very different from each other based on a lot of different characteristics. For example, their melting points are very different. Their solubilities in water are very different. Their reactivities with oxygen are also very different. In today's lab, we are going to examine yet another characteristic that differentiates these 3 compounds from each other, and that is conductivity. We are going to be tossing in a 4th compound, acetic acid, for this analysis. So are you ready? Let's get started. To set up this lab, I want you to pay close attention to the quantities that are already written in your lab protocol. We have pre-measured sodium chloride, 0.23 grams of it, the sugar, 1.43 grams, and the sodium bicarbonate is 0.35 grams. Those numbers are going to be very significant when you get to the analysis part of this lab. Vinegar, we have measured out 5 milliliters of vinegar. Commercial vinegar is a 5% solution. Again, that value is going to be significant when you do the analysis for this lab. So in addition to our samples, we have 4 beakers, 100 milliliter beakers, to which we have added 25 milliliters to each of distilled water to each of these beakers. I have my usual wash bucket and a wireless conductivity sensor. In SparkView, I have opened the Essential Chemistry Lab number 10A, and that is specifically designed for the types of bonding lab. So now that we have all of the materials set up, let's get started with the procedural portion of this lab. So to begin this experiment, we are going to take each of our white substances and we're going to be adding it to the water that's in the corresponding beaker. So that's our 0.23 grams of sodium chloride being added to its own beaker, 1.43 grams of sugar. Here's our vinegar, 5 milliliters pre-measured. We're going to throw that in as well. And finally, our bicarb, sodium bicarbonate being added. And I put these little stir bars in here just to make sure that everything goes into solution, because it's difficult to measure solution conductivity when not all of your material is actually dissolved. That one looks good for sodium chloride. Looking really good for the sugar. Here's our bicarb. It's getting there. And for the vinegar, we're just going to give it a nice little swirl. So now we have our 4 solutions. It's time to get ready to measure the conductivity. And I've already used our Bluetooth connection to set us up. Again, this is experiment 10A under Essential Chemistry. Let's start with the table salt. I'm going to press the start button here. And that seems pretty much hovering around 14,000. Let's rinse this out. Let's see what sugar looks like. Look at that. Table sugar is reading about 4 to 6. Let's give that a little check. Our vinegar solution is reading approximately 615. Let's give that a little check. And our last one is baking soda. Ooh-wee, look at baking soda. And we'll give that a check. So now we have the conductivity readings for every single one of our solutions. It's time for us to think about what these solutions are in terms of the kinds of bonds that hold their molecules together. The conductivity of a compound in solution really depends on its ability to form ions in solution. Of the compounds that you tested today, I want you to look at the data and determine which ones of your samples from today produced enough ions to show significant conductivity. There's a huge difference in the ability of ionic compounds to conduct as opposed to covalent compounds. That should give you a clue as to what your different compounds are. It will also help if you actually construct models of these molecules for you to understand the differences between ionic and covalent compounds.